When you look up at the night sky, we see our home galaxy, the Milky Way, as this serene, beautiful band of light. But what if I told you that calm picture hides a really dramatic history and a structure that's way more complex than we ever imagined? So let's get into it. This is a story that's literally written in the stars. I love this quote because it just perfectly captures what our galaxy is. It's not some lonely object floating out in space. No, it's the heart of a huge cosmic family, a system that's constantly interacting with all of its neighbors. So let's start right there. Let's meet the family.
Okay, so before we dive right into the Milky Way itself, we got to understand its neighborhood. See, our galaxy is kind of the big cheese in what's called the local group. It's surrounded by dozens of smaller galaxies, all of them tangled up together by gravity.
And what you get is this incredible slow-motion cosmic dance that's been going on for billions of years. You've got the smallest of these galaxies caught in our orbit, circling us just like moons around a planet. Others get a little too close, and they're slowly pulled apart by our gravity, dissolving into these long, beautiful streams of stars. And then some just kind of drift nearby, tethered to us in this huge, invisible web of motion. And the key thing to remember here is this whole setup, it's not static, it's always changing. Over these immense timescales, galaxies merge, they fade away, they get absorbed. It means our Milky Way is constantly growing, always being shaped by these gravitational get-togethers.
All right, so we've seen the neighborhood. Let's head home. And the first thing you'd notice, the biggest feature of the Milky Way by far, is its massive spinning disk of stars, gas, and dust. That's where we live.
Yeah, we've all seen those amazing artists' pictures, right? This majestic, flat, spiral galaxy. It looks like one single structure, a simple, spinning cosmic pinwheel. It's an iconic image. But, and this is the really cool part, it's also a little misleading. Because what really happens when we peel back that familiar layer, when we look closer than those postcard pictures, what secrets is that giant disk actually hiding? Okay, here it is. The big reveal. The Milky Way's disk isn't one thing. Not at all. It's actually two completely separate structures, nested inside each other, like cosmic Russian dolls. There's a thin disk and a thick disk. And believe me, these two parts could not be more different. So you and I, we live in what's called the thin disk. That's the busy, dense, wide part we're familiar with, just packed with young stars and all the gas needed to make new ones. But then, wrapped all around it, above and below, is the thick disk. And it's much older, it's puffier, and way more spread out. Right, and just to make sure we're all on the same page here, when we say galactic disk, we're talking about that main, flat, spinning part of the galaxy where, most of the stars and gas hang out. But as we're finding out, our galaxy's disk has this secret layered personality. So you're probably wondering, how on earth do we know any of this? I mean, it's not like we can just fly out there and take a picture of a cross-section, right? Well, what astronomers do is kind of like cosmic archaeology. They use these incredible missions like the Gaia Space Telescope to map out billions of stars, and then they analyze their light to uncover the galaxy's hidden history. Which brings us to the big question. What is it about the stars in the thick disk that just screams, hey, I've got a totally different backstory than that thin disk? Well, the answer is right there, in the starlight. It turns out the clues are literally written in the stars. First, the stars in the thick disk are ancient. We're talking way older than stars like our own sun. Second, their chemistry is different. They have fewer heavy elements, which is just astronomers speak for anything heavier than hydrogen and helium. That's a huge sign they formed super early in the universe's history. And third, their orbits aren't neat and tidy. They're all over the place. Tilted, stretched out, a dead giveaway that they were seriously disturbed a long, long time ago. So when you put all that together, it doesn't sound like a quiet, calm history, does it? No way. It points to a past that was way more chaotic, way more violent. And all of this evidence points to one incredible theory. The idea is that the thick disk is basically a fossil. It's the leftover remnant of an earlier, smaller version of the Milky Way that got completely puffed up by collisions. As smaller galaxies crashed into ours, their gravity literally stirred everything up, scattering those older stars into the wider, tilted orbits we see today. And then the thin disk, our home, formed much, much later, settling peacefully inside this older, more chaotic structure. All right, so let's pull back and look at the big picture here. Realizing there are these two separate disks, that completely changes how we see our own galaxy. It shows us that our home isn't some finished painting, it's a living, breathing, evolving structure. It means that every single star is like a tiny time capsule. The young stars right here in our neighborhood, in the thin disk, they tell a story of calm, recent creation. But those old stars in the thick disk, they tell this wild tale of ancient smash-ups and cosmic chaos. Our home has deep layers, both literally and historically.
And, a discovery like this just goes to show how much we still don't know. It really is like looking up at a giant history book, written in a language we're just now finally learning to read. And it just makes you wonder what other incredible ancient stories are just waiting for us to find them hidden up there in the stars.